Good day, everyone. This is Dr. Janet F. Rabut. Please listen carefully as I discuss to you this topic, finding the limits of a function. Our objectives for today's lesson are: first, define limits of a function. Second, estimate the limits of a function using table of values. Third, find the limit using a graph of a function. And fourth, distinguish if the limit of a function exists or not. Let us now consider the relationship between the limit of a function at a point and the limits from the right and left at that point. It seems clear that if the limit from the right and the limit from the left have a common value, then that common value is the limit of the function at that point. Similarly, if the limit from the left and the limit from the right take on different values, the limit of the function does not exist. These conclusions are summarized in here. So let's say let f of x be a function defined at all values in an open interval containing a, with the possible exception of a itself. So a is not included. And L be a real number. Then, the limit of f of x as x approaches a equals L. That is the definition of limit, right? If and only if the limit of f of x as x approaches a negative or numbers less than a equals L, and the limit of f of x as x approaches a positive or greater than a equals L. Now let's have an example. Now we will going to estimate the limit of f of x is equal to 8 minus x cubed all over x squared minus 4. So in here we will going to estimate the limit by using these values from the left of our a and from the right of our a. So let's say we have here 2.5, 2.1, 2.01, 2.001, 2.0001, 1.5, 1.9, 1.99, 1.999, and 1.9999. So here it is. Since we are estimating the limit, using this table is a very big help. So I assume that the numbers from 1.5 to 1.9999 are the limits from the left of a, and the numbers from 2.0001 to 2.5 are the limits from the right of a. I know that some of you may be asking, how are these values of f of x being solved? So I will show you how. For example, our x is 2.5. What is f of x? From the original function, which is f of x is equal to 8 minus x cubed all over x squared minus 4, we will going to plug in the value of our x, which is 2.5. So we have here f of x is equal to 8 minus 2.5 cubed all over 2.5 squared minus 4. This is equal to 8 minus 15.625. How did I get this 15.625? That is coming from 2.5 cubed, wherein I multiplied 2.5 3 times. So that is 2.5 times 2.5 times 2.5. Okay, so all over 6.25 minus 4. Again, 6.25 here comes from 2.5 squared, which is 2.5 times 2.5. So this is now equal to negative 7.625 when we subtract 15.625 from 8. So we will get negative 7.625. Then 625 minus 4, that is 2.25. So when we divide these numbers, we will get negative 3.38889. In other words, if our x is 2.5, our f of x is negative 3.8889, and that is true, no? Showing the table. Another example, if our x is 1.99, so from the original function again, which is f of x is equal to 8 minus x cubed all over x squared minus 4, I am going to plug in the value of our x, which is 1.99. So I have here f of x is equal to 8 minus 1.99 cubed all over 1.99 squared minus 4. So it is equal to 8 minus 7.880599. So this 7.880599 comes from 1.99 cubed, no? Again, multiply 1.99 3 times. Then all over 3.9601. So 3.9601 comes from 1.99 squared. Minus 4. So operate that one, we will get 0.119401 all over negative 0.399, and the value of our f of x is negative 2.99251. And that is true again from the table. So as you can see, the limits from the left of a and the limits from the right of a are almost the same. If we will going to round off each value of f of x, we will get negative 3. In other words, our limit exists. That is the limit of 8 minus x cubed all over x squared minus 4 as x approaches 2 is equal to negative 3. Okay, I hope I made myself clear here. There are many examples in the module I gave you. Please practice if you have time. This time again, we will going to find the limits of the function through its graph. For example, showing the graph on the right, we are asked to get the limit of the function, or should I say the limit of f of x as x approaches a. It is natural that we will going to get the two-sided limits here because we are given as x approaches a, not just x approaches a negative or a positive. So we need to find f of negative 4, f of negative 1, f of 2, and f of 4. Now look at the table. We will find f of negative 4. When x approaches negative 4 from the left of a, the limit is at point negative 2. While if x approaches negative 4 from the right of a, the limit is at point 3. And take note, the other point is closed at 3 while the other point is open at point negative 2. What does it mean? Since the two-sided limits are different, wherein we can see that the limit of f of x as x approaches negative 4 from the left of a is negative 2, while the limit of f of x as x approaches negative 4 from the right of a is equal to 3. Therefore, the limit of f of x as x approaches negative 4 does not exist. Next, find f of negative 1. The limit of f of x as x approaches negative 1 from the left of a is 4. And the limit of f of x as x approaches negative 1 from the right of a is still 4. There is no other point we can see, and that point is closed. Therefore, what does it mean? Since the two-sided limits are the same, or should I say, from both sides, the limit approaches the same value. That is, the limit of f of x as x approaches negative 1 from the left of a is equal to 4, and the limit of f of x as x approaches negative 1 from the right of a is equal to 4. Therefore, the limit exists. I hope that this time mas klaro na talaga. We will now find the limit of f of 2. Again, focus on the table. When x approaches 2, there are 2 points exist. The other one is from the left of a, which is negative 1, and the other limit from the right of a is 5. What does it mean again? Then again, we can see the limit of f of x when x approaches 2 from the left of a is equal to -1, and the limit of f of x as x approaches 2 from the right of a is equal to 5. Therefore, the limit of f of x as x approaches 2 does not exist. And finally, let us find f of 4. Now eyes on the table. By looking at the point on line with x equals 4, we can see the point at 2 which is open. By that alone, we can say that the limit does not exist. But since we are asked to find the limit, and obviously there exists a point from the right of a, it means that it is possible that one-sided limit can have a value. So here we have the limit of f of x as x approaches 4 from the left of a is equal to 2, and the limit of f of x as x approaches 4 from the right of a is equal to 2. That means that both sides are approaching the same value as x approaches 4. Even the two-sided limits are the same, or both sides of the limits approaches to the same value, which is 2, still the value of the limit depends on the values of the function around the point in the question. So we can say that the limit does not exist at this point. That ends our lesson for today. I hope that you learn how to estimate the limits of the function using a table and how to distinguish if the limits exist or not. Thank you very much for listening. If you have questions, you can message me to our messenger group chat. Bye for now.